Hello and welcome to the training video series for ParallelFox. My name is Joel Leach. I'm the author of ParallelFox, which is a parallel processing library for Visual Fox Pro. I am very excited about this project. Yes, this is be excited, I know. But the reason I am is because I believe that parallel processing is very relevant to developers today, and that includes Fox Pro developers. So why is it relevant? What's the big deal about parallel processing today? It's certainly a buzzword these days. Microsoft just added the parallel extensions to .NET 4.0. There's a lot of other libraries for other languages coming out, and overall it is getting a lot of attention. It started a few years ago, and overall my thought was maybe that's too much attention. You know, what is the big deal about this? Multi-threaded operating systems are the core technology that enable parallel processing, and really those have been mainstream on PCs since Windows 95. And that goes back even further on other operating systems. I used OS2 back in the early 90s. Early versions of Windows NT were around about that time, and you could do multi-threaded programming on those operating systems. So running multiple programs at the same time or a background task has been possible for years now. And if you really needed to run something in the background in VFP, you could always just create a separate executable and run /n. So the underlying technology for parallel processing has been around for quite a while, but it's just now in the last few years been receiving a lot more attention. So why is that? Well, it really comes down to hardware. The primary reason is that CPU makers ran into a brick wall a few years ago. CPU speed topped out somewhere between 3 and 4 megahertz. The CPUs were just getting too hot, drawing too much power, and they really can't make it go faster without using or changing to materials that are much more expensive, and that's just not economical. Now, up to that point, we basically got free performance increases when our clients bought new hardware. And this may be more true for Fox Pro programmers than others because the system requirements haven't really changed that much. They've been pretty level since VFP3. It's not like a VB developer, VB6, took quite a jump in resources to go to .NET, or C++ programmer moving to Java. You know, those run times take a lot more resources, and Fox Pro programmers have not had to take that kind of hit in the last few years. Unfortunately, the free lunch is over. There are still improvements in the efficiency of CPU speed, but they're small incremental improvements, maybe a few percent here and there. So we're not seeing the megahertz. We still haven't really got up to 4 megahertz at this point. So there's not much speed increase in individual CPU cores. But while CPU makers could not make the CPUs much faster, they can still make them smaller. And this is allowing them to put multiple cores on one chip. And that's what we have today. Your average new desktop computer is going to come with 4 cores. Average laptop is going to have 2 cores on it. You can get 4 cores on a laptop, but probably the average lower end laptop is going to have 2 cores on it. And unless you get down to smaller devices like netbooks, it would be pretty difficult to find a single core machine today. And Fox Pro is going to use the equivalent of a single core. So on a quad core machine, that means Fox Pro is going to use only about 25% of the processing power available on that machine. The latest processors coming out of Intel and AMD for desktops have 6 cores. In that case, Fox Pro is only going to use 17% of the power available on that machine. When you look at server CPUs, it even goes higher. The latest Intel server processors have 8 cores. The latest AMD server processors have 12 cores. So the race is on, and it's no longer about megahertz, it's about how many cores can I pack into a single package. And so the cores are coming, and it's going to keep increasing like it is. So the processing power is there, it's available, we just have to go get it. And this change in hardware is actually taking parallel processing from the domain of specialty or large-scale systems to something that all programmers need to be thinking about. So if you're a programmer writing programs for CGI processing in movies, or a programmer that works on the Windows team at Microsoft or the SQL Server team, you've been doing parallel processing and multi-threaded programming for a long time now. But if you're a developer that has been doing line of business applications, working with data, things like that, it's not really something you've had to think about in the past, but now we're seeing that change. This also means a change in mentality. You need to start thinking in parallel. In the past, technology was primarily used to run multiple programs on a single processor. Now we need to take a single program, divide it up so that it can run on multiple processors. And once you dive into that, it doesn't take long to realize that run/n just doesn't cut it. Asynchronous execution, worker pools, message handling, message queues, the list goes on. There's just a lot more to it than meets the eye. And it's hard enough to start thinking about running code in parallel without having to deal with the plumbing. Now you'll hear some people say that multi-threaded or parallel programming is kind of the domain of a special few programmers, that only the best or the high-end developers can handle that. I don't believe that's necessarily true. I mean, we're programmers, we're pretty smart, I think we can handle it. What I do think is that the amount of effort involved in doing it, parallel programming, and the level of difficulty is out of proportion with other tasks that you can perform in the same language. So even with, C, C++ programmers, they live for this kind of stuff, and multi-threaded programming is one of the more difficult things that they have to do. So that's why we have the parallel extensions for .NET. We see libraries popping up for all of the major languages, and that's why we have ParallelFox now. It's really to raise parallel processing to the same level as the rest of the language. Now, while ParallelFox shares the same goal of making parallel processing easier and more approachable, that's really where the similarities end with other tools. And there are several goals that I specifically have for ParallelFox. The first is to do things the Fox way, make it easy to use and natural for FoxPro developers. So this is not a port of the .NET parallel extensions or some other library. First of all, I couldn't do that if we don't have that level of access to the FoxPro runtime or the FoxPro engine. But besides that, I think it would feel pretty foreign in the context of FoxPro. Along those same lines, I wanted to, as much as possible, make it feel like an extension of the Fox language. Of course, there's only so much we can do. I can't get into FoxPro and add new language keywords or statements, but do what we can to make it feel like it is part of the language. Also wanted a full-featured library that supports the full functionality of VFP, and it just works without having to jump through a lot of hoops. So if you want to run a report in the background, that works with ParallelFox. And this next one is very important to me, and I think very important to the whole FoxPro community, and that's that it has to work well with existing apps, existing code. For example, while some in-tier concepts come into play, you don't have to refactor your entire app as in-tier to take advantage of ParallelFox. I know how it is to receive a constant stream of requests from clients who, by the way, are paying cash money for that work, so that doesn't leave much time to get the rest of the app how you would like to have it. So maybe you have some code where it's not supposed to be, it's not split up into the tiers like you would like it to be. That's okay. There may be a little bit of upfront work you have to do to get ParallelFox running with your app, but you're not going to have to rewrite the app or refactor the whole thing. For the most part, it'll work with the code that you have. So if there's one piece of code that you think can benefit from parallel processing, for the most part you can concentrate on that code and make the necessary changes, and that will run. You can take advantage of ParallelFox. So those are my goals. I'll let you be the judge and decide if I met those or not. And those goals may change as this gets out in the community and we hear about the needs. Then those may change. And so my final goal is that ParallelFox does evolve to meet those needs. And I hope you'll participate in that process and use it and provide some feedback. Okay, so let's take a look at how ParallelFox works, and just an overview of that. To start, we have the main process, which is basically the app executable running the code that you have now. It contains your user interface and all the rest of your code. And in the context of parallel processing, the main process pretty much runs the show. We also have worker processes. These are separate instances of VFP, usually one for each CPU core, though you have some control over that. And these assist the main process and are used to run code in parallel. Now, these are separate processes rather than threads that run inside the main process. And the primary reason for that is so that we can support the full functionality of Fox Pro. But in my opinion, processes versus threads is really only a small percentage of the whole picture when you're talking about parallel processing. Now, when you tell ParallelFox to run a piece of code, it puts that request into a queue. And as that queue is processed, a command is sent to the next available worker. And the worker then executes the command and then notifies the main process when the command is complete. Now, there are a lot of places where you can be involved in that process, but that's the basic flow. Going back to the subject of thinking in parallel, let's talk about synchronous programming versus asynchronous. Now, synchronous programming is programming as we know it, as we've been doing for years. One line of code runs at a time, and it does so in a sequential manner. Step 1 starts, step 2 doesn't start until step 1 is complete, step 3 doesn't start until step 2 is complete, and so on. To put that in more technical terms, when one program calls another program, control doesn't return to the first program until the other program is complete. And that is true even when you're talking about COM objects. Let's say you're doing some word automation and Fox Pro tells Word to perform a mail merge. While that mail merge is running, Fox Pro is going to wait around for that to complete. Even though they are in separate processes, Fox Pro won't continue with the next line of code until Word has finished performing its task. So this synchronous sequential method of programming, it's what we've been doing for years, and it's pretty comfortable. Parallel processing requires running code in an asynchronous fashion. So you need to think can step 1 and step 2 run at the same time? Step 2 may finish before step 1 completes. Is that going to cause some problems in my program? So when one program calls another program, there's going to be some overhead to make that call, but then control is immediately going to return to the first program. So with that same word automation example, what if you told Word to start the mail merge, and then FoxPro immediately ran the next line of code? That would be a more asynchronous way of doing things. And that's the kind of situation that ParallelFox enables. And that does require a different mindset. Maybe it's not so comfortable, right? It's hard enough to think about a bunch of different things going on in sequence, but when you have some of those things running at the same time, it can boggle the mind a bit. But hopefully ParallelFox will help in that process. Again, I'm really looking forward to getting this out there and hearing what people like, hearing what people don't like. If you do use ParallelFox and find any bugs, please post those on VFPX in the issue tracker. Or if you have any questions or comments, please post those in the discussion area of VFPX. So that is my introduction to ParallelFox, and that's enough talk. Let's look at some code, and that's what we're going to do for the rest of the videos.